In this question, we are required to determine the exact coordinates of the points on this curve where the tangent line is parallel to the y-axis. Now you can try to imagine where a tangent is parallel to the y-axis. That implies that it's vertical. And we know that for vertical lines, the gradients are undefined. So basically, this condition here, where the tangent is parallel to the y-axis, that implies that the gradient is undefined. So the gradient is undefined. And that implies that the change in x is actually 0. Yeah, because this tangent is vertical. Okay, so moving on, we shall find the curve that represents the gradient of this given curve at any point. So dy over dx. So basically, to find dy over dx, we have to differentiate term by term. So d over dx of x cubed plus derivative of y cubed minus derivative of 3xy. Which will be equal to derivative of 0. Anyway, which is just 0. So from the left, this will be equal to 3x squared. And here, that will be 3y squared dy over dx. And then here, what we shall do is to apply product rule, because we have a product of two functions. So 3x d over dx of y plus y multiplied by the derivative of 3x, which will be equal to 0. So this will be 3x squared plus 3y squared dy over dx minus 3x dy over dx plus 3y is equals to 0. So basically, if I remove these brackets here, I'll have 3x squared plus 3y squared dy over dx minus 3x dy over dx minus 3y is equals to 0. Now, if we group this together, we'll have 3y squared minus 3x dy over dx will be equal to 3y minus 3x squared, which implies that dy over dx will be equal to 3y minus 3x squared over 3y squared minus 3x. And basically, that is the gradient function. Now, what we're saying here is that the change in x is 0. So the change in x is 0, which implies that this is 0 and that is equals to 0. So the change in x is equals to 0. So that implies that this should be equal to 0 at the given points that you're trying to look at, where the tangent line is parallel to the y-axis. So if we equate this to 0, so we have 3y squared minus 3x being equal to 0. That implies that, if you do, so that will mean that 3y squared will be equal to 3x, which means that y squared is equals to x. Okay, so how does this condition help us? Well, we can go back to the original equation and substitute this back into the original equation and then solve for the corresponding x coordinates or y coordinates. So what we shall do is we shall replace y squared in place of x, makes it easier. So if you replace y squared in place of x, you'll end up with y squared in place of x here, so cubed, plus y cubed minus 3 multiplied by y squared multiplied by y will be equal to 0. So basically what we'll end up with is y to the power 6 plus y to the power 3 minus 3y cubed is equals to 0. And this is same as y to the power 6 minus 2y cubed will be equal to 0. And then you factorize out y cubed, so y cubed into y cubed minus 2 will be equal to 0, which implies that either y cubed will be equal to 0 or y cubed will be equal to 2. So from here, it follows that either y is equals to 0 or y is equals to the cube root of 2, which is just 2 to the power a third. All right, so and then that implies that, I mean, if you substitute here, it follows that at y is equals to 0, you can see that x will also be equal to 0. So the first point will be equal to 0, 0. And then at y is equals to 2 to the power a third, it follows that x will be equal to 2 to the power a third squared, which is 2 to the power 2 over 3. So the other point will be 2 to the power a third for the x coordinate. Sorry, 2 to the power 2 thirds for the x coordinate. And then for the y coordinate, it will be 2 to the power third, what we have here. So 2 to the power third. So this basically will be the required solutions. So the tangent line is parallel to the y-axis at either 0, 0 or 2 to the power 2 thirds for the x coordinate and 2 to the power third for the y coordinate. And those will be the required points.